Welcome back everyone. Now we are going to learn about the machine instruction. So as I promised, it's about the assembly language. So we are gonna see that how the assembly language actually work, why it's required, and what are its commands. So assembly language is all that we need to learn here. Well, what is the assembly language? Well, this is the intermediate coding language that includes the numbers and symbols and alphabets, you can say. That's all what it is. Like you can write a d d a comma b, so it can be understandable that we are adding a and b. Now this is how the assembly language programming actually works. That's how we are writing it. So machine instruction includes some instruction for various operation in the processor that can be converted into binary codes. Like when I say that it's addition, what actually happened? Machine don't know that it's addition or not. So what it actually has to do, it has to go through a definite code that is inbuilt in this. So when you press this positive button in any of the machine or give the command of the positive, a code is started executing, and that code is written surely the only language the machine actually understand in the binary, and that's how our action is performed for the particular addition. So the translation is done by special program which is known as assembler. So assembler will going to act as our translator, and the programming language we are using is the assembly programming language. So we are writing the assembly program, and that assembly program will going to go through the assembler that is going to convert our assembly programming language into machine language, or in simple words in binary codes, and that's how the machine is actually going to work. Like I previously gave the example of the calculator, like we have 5, 2 and all the numbers which is written. So when you press the 5, what actually happened? The code inside it actually converts that 5 into 101. That's the binary language, and this binary language is going to operate through a definite architecture that is physically inbuilt in the capacitor, resistance and all that such things, and then we are going to get our particular result whichever the operation we actually perform, or just simply display the number 5. So everything happens in the binary, but we require a simpler version of it. So everything which is done and our subject is done in the assembly language. So that's the importance of the assembly language. Now let's learn the programs of the assembly language, few of the things. So you're going to see that how the instruction, what is the format, and what is its description. So let's start with the simplest one, which is add, A D D. So how we write it? Let's say we write A D D add B. So what it actually means? It means add register B, register B to register A, to register A. Here A with means with the accumulator. I'm writing it here. Accumulator. So A act as accumulator, and place unit. Place unit, or let's say result, in A. That's how it works. Now let's see the second one. So we have here add, or let me change the line, add M. So what is the meaning of add M? It means add memory. Add memory M content, whichever the content is stored, a picture, a movie, a data, or a doc file, whatever way you like to call it. in the A accumulator. A is accumulator, and place result in A. Result in A. So why we are using the word accumulator simply means that it gather or collect every data, and then according to the accumulation it shows us the result. That's how it happens. To understand it, let's have one more. Add A comma B, the example that I gave you. Now it means add A, which is our accumulator, and B, and place result in A, which is our accumulator. So the thing what is happening is actually working in such a way that let's say let me change the color so that I can explain this. Let's say you are saying add A comma B. So what actually happens? Let's say A is equals to 2 and B is equals to 3. So this is all the thing. So what happened? 2 plus 3 gets 5, and that 5 is going to store and update the value of A. So now the value of A that we see is actually 5. This is how all the programming languages made. Mostly all the programming languages are made on this basis, because this is a way by which the assembly language is working, or the way the machines are mostly designed for the programming language purposes. So that's how it is memory efficient. Otherwise we require more and more and more space, which is not efficient. Now you can understand that why it require a ton big computer, or that much picture, that if you have seen that how much big the IBM's 5 MB memory space was, it was incredibly insane. We have smaller computer than the memory itself. From that time we can have the size of the supercomputer. Sometime I feel like that. So that is the reason. Now we learn to use the memory efficiently. So that's how we do the things. Now let's have A D1, data or data, whichever way you like to call it. It means add immediate add immediate data to A, which is our accumulator, and place the result in A. Place result in A. So it's about the immediate. So what you have to take it? Well, we are applying addition, but how many kind of the addition are there? Well, the addition can be add register B to register A. We are extending something. We are having add memory M to the content A. We have adding, we can call it as operation, and we have immediate data. Let me explain that one after another so that we can understand that why we need that many formats. Well, in the first one we are having register, add register B to register A. Imagine that you have a file. Let me open a new page for this. You have a file whose name is A, and a folder. Let's say its name is Genius. So in the Genius folder, you want to place your A plus file. So how you do that? Well, just cut that file and copy it here, or paste it here actually. So you just paste it here, and now it's in the folder that we have. So we have a folder inside our file. That's what it means. Add register B to register A. So the information of register B, let's say this is register B and this is register A. So the information of B get transferred or added to register A. That's what it means in the first one. I hope you have got that. Now let's see that what happened in the second one. We are adding the memory M to the content A. What does it actually mean? Let's say we have 2 MB file, and you're again having a folder, or let's say you have a pen drive. It is having 2 GB space free. Now what you can do, you can just copy it and paste it, or just cut it and paste it here. So this is the free memory, right? So now it's not free, it is having 2 MB. So 2 GB minus 2 MB space is left for us in our pen drive. That's what actually happened. So this is the meaning of adding the memory. Adding memory. Previously it was empty, and now we added the 2 MB here. So this is for the second one. I hope you have got this too. Now let's study the third one. We have having the operation for the third one that we have seen so many times. Let's write it here. Like in the programming language, we used to write A plus B, and this is all it. And A is equal to 3, B is equal to 5. This is what we give. So A gets updated with 3 plus 5. So the answer A is actually storing is 8 and not 3 anymore. 3 is initialized but not 3 anymore. 8 gets updated with 8. So that's what actually happened when you do the programming. And this is how we have to design our digital electronics circuit, either digitally or physically, both ways, so that we can do the operation in this way. That's what it takes. Now the final one, it add immediate data to A. Well, immediate data to A is simple, that you are adding some data to a file, or you are adding a file to a folder. That's it. Or you are just adding some new information to the previously saved folder. That's what all it means. Okay, I hope you have got this thing. And now we can proceed to the next level, which is our, let me draw the lines first. Okay, the line gets tilted sometimes. Alright, now we're going to learn about the subtraction. So, SUB. Well, I'm writing it in capital letters so that you will get familiar with the assembly programming language along with studying the digital electronics. So this is one of the purpose. I am doing it purposefully, because in this we write everything in the capital letter, as you can see here. Okay. So in the subtraction we have SUB, subtract B. Then we are going to have SUBM for the memory, SUB A comma B, and then we have SBI data. Well, I hope the first three ones are already known to you, because on subtraction B means subtract register B, subtract register B from A, which is our accumulator. That's just the name, don't get confused with this. You can just open the dictionary and see the meaning of the accumulator. That's it. That's all what it means, nothing else. And place the result in A, and place the result in A. Just the same way we do for our addition. Just the operation is changed here and nothing else. In this we are having subtract memory from A. I'm writing in short way. I will explain that also in just a while. In the third one, we subtract the result, subtract A and B and store the data in a store result in A. Okay. Now the fourth one is left. Before we reach to the fourth one, let me introduce you with the first three things. So, in the first one, as you can see, my dear friend, that we are having register B and register A. So, register B from register A is subtracted. It means just simply, if I write it this way, we are having a folder already, and in that folder there is already a file A. Now if I choose to cut it and paste it somewhere else, or let's say I just simply delete it, delete A. If I delete A, the memory gets free, memory gets free, which was occupied by A in folder. So this is the first thing. And the another thing that actually this is the second point, if you notice that here. So we have covered the second point. And the same way, if you focus upon the data of it, data of A gets removed, obviously removed from folder. So that's what it means through the first point. I written the first point here. Okay. Now the next thing is storing the value. So as we know, storing the value means A is equal to A minus B, or let's say B minus A, whichever way you like to call it. Now 3, 1 minus the answer is 2, 2 gets updated in A. So the final result for A is equal to 2. So A gets updated. That's what it means. Now we come to this one, which is SBI data. Well, it simply means subtract immediate data from A. Well, this process actually comes up when we require to update our value. So sometimes we need to store it, sometimes we need to subtract it, like A is equals to A plus B. So in this case we need to add it up, and in this case we need to update it. So this is what it means. Immediately subtract the data. Like 2 is get updated from the result 1. So A becomes 1. Here I present it. A is 2 initially and B is 1. On subtracting we are going to get the 1, and A's value is now not 2 but 1. So this is what it means. I hope you have understood this quite clearly. Now let's learn few more commands. It is getting interesting, right my dear friend? So let's learn more things. So we have LDA, which is LDAM in the format, and its description is quite simple. The content of memory M to A. Content of memory M to A. Well, LDA means load. That's it. Nothing else. STA. Well, it is written as STAM when you write the instruction. It means state the content of register A to memory M. State the content of of register A to memory M. So it's about the state the content. You can say state the address to memory in the simple words to understand that. Now the next one we have here is CMA. So we are going to write CMA here, and the CMA means complement. Complement A. A is accumulator. Accumulator. Now the next one we are having is MOV. MOV, as you know, it means move. So move R1, R2. It means move the content of R2 in the the register R1. You have to remember that always these gets the stored. Okay. Now let's proceed to the next command, which is DCR. DCR. So instruction DCR written as DCR. Let me write it clearly. DCR R1. So what it actually means, I'm changing the color. So it means decrement of R1. Now similar way we are having I N R. INR R1. It simply means increment. Increment R1. Remember that plus plus thing and minus minus thing in the programming. This is what it actually means in the digital electronics. That's how we design it. So the next one we are having is CMP. It means compare. CMP R1. So in this, simply we compare R1 with, if nothing is written, it's always mean with the A. A is accumulator. Well, you can write instead of the A, you can write B, C, D, E, F, or any way you want it. I'm just taking the A because this is the standard form how we take it. First reason, second reason, A is the first letter, so why not? So that's all it. INP is the next instruction, and in the format we write it INP data, DATA data. So it input data and clear the flag. Input data and clear the flag. Well, if you know about the flag, it's good. If you don't know about the flag, let me clear that about. So flag means the previously stored value. That's all you want to know for right now. That's it. The previously stored value that we have studied, like A is having 2 and B is having 1. Now in addition, A becomes 3. So this flag value gets eliminated. Well, that's how you can learn it for now. But there is a little different meaning on the calculation part that I will explain a little later. Well, you already know that. You can just think that how the flag value actually works. So the flag value actually means with a simplest of the order. Well, what I mean with that? I mean with that when we take the carry or borrow that we studied in our thing, so that are the flag values that we require it for a moment, but after we get the result, it will not be required. So these are called the flag values. I just explained it to you. Okay, now let's come to the next command, which is out. So OUT data, in which we are going to write output data. Output data and clear flag. So it is very important that we clear the flag. When any engineer on the planet learns a Python language or C language, they usually learn about the clearing. How much clear is your garbage by writing the values, how much efficiently you're using the memory, that much efficient you are making the software, or in our case, electronics. So this is how the things are actually working. Everything based on some logic as usual. So HLT, it's called as halt sometimes. I'm writing it HLT, to HLT process, to halt process. Okay. Now the next thing we have is LXI. So I'm writing it LXIH 2050. Well, I will explain it later. It means load immediate, load immediate data to H1 pair. Well, for now you can consider it as the memory, and this is the H. That's it. Nothing else. Just the data. Okay. So these are the commands that we learned in the assembly language. We have came through a long way of the commands. So these are the basic commands, instruction, format, and I also wrote its description so that you can understand everything clearly. So if you write LDA, it will load the content. If you write ADDB, it means it will register your B to A. If you write ADDM in the assembly language, it means you are adding some memory. If you write SUBM, it means you are subtracting the memory. So that's how the things happen actually. So congratulations my dear friend, you just learned the keywords of the new programming language which is known as assembly programming. And assembly programming is one of the most powerful invention in the computer science and digital electronics history. Why I am saying so? Just imagine that till this date I am teaching you this. It means it is working. It is working every single day in the digital electronics. Nothing is more efficient than that. And this is the key basis of any of the advanced programming language that you can ever imagine. So that's how the things happen. So with all that said, that's it for the machine instruction and the assembly programming. See you in the next one where we are going to learn about the subroutines. So till that time, take care, God bless, keep revising, keep learning and keep growing. Sayonara.